I've got quite a quick video for you today, and on previous videos I've shown you this board. Now don't worry, because I'm not going to test it again, but you may recall I've said this board blew up after a short period of time and that they are not suitable for 48 volt operation. And I suspect that the reason is because of this chip here, because I think they're fakes. Now this particular board, something's blown up in that area, and the new board that I've got, which I've shown you a few days ago in fact, that particular chip, which is a 12 volt regulator, switch mode regulator, which runs the preamp basically, just gets very hot, and there's no real reason for it to get hot because the consumption of the 5532s is about 8 milliamps, and this particular chip is rated at 800 milliamps, so we're not really working it hard. And it's capable, if you believe the manufacturers, of operating with an input of up to 80 volts. So if we're putting 48 volts into it, we're not really giving it a hard time, are we? But if they're fakes, you don't know what that component is. And I've tried to get some genuine ones here in New Zealand, and Farnell and RS Components don't stock it and have never heard of it. So whether it's obsolete or just a Chinese one, or someone's making them in their back garden, I don't know. Now this little board is very basically exactly what is used on the Class D amplifier. Here you can see the chip in question, the inductor and peripheral components. The only difference is this power supply has a preset pot here, and you can dial in your own output voltage. But the basic chip itself is rated at up to 80 volts. As you can see by this conglomeration of cables, how small this actually is compared with my hands. It doesn't need to be any bigger than that, of course, and it takes up even less space when you've got it on a board. But all we've got here is a little fan, which is, as I've said, to act as a load, so that, I mean, there's no way this is going to overload it. All we need to look at on the test meter is a nominal 12 volts, which I shall set this up to read. And if I put the power on, the fan is going round, and you can see we're drawing about 60 milliamps. Now so far so good. Now I've got 24 volts going in, and if I gradually turn the voltage down, you will see the 12 volts remains pretty constant, certainly good enough until we get below its capabilities. Now it's already going down, and with 14 volts on it, but that's not really a problem because it's the higher voltage is the issue. So we'll go up now, and if I get my hand out of the way, how can I do this where you can still see me? I'll keep turning the voltage up until something happens. Bear in mind we should be able to go up to 60 volts at least. We've still got roughly 12 volts, and we're up to 40. $50 volts, and now we're starting to lose voltage on here, and now it's gone. 52 volts, and we've got 17 volts and the stability is just gone and the fan's going berserk. So it looks like right where the 48 volts is, it's on the point of going unstable. And let's see. At the moment, it's beginning to get quite hot. So clearly at 50 volts, the stability has gone. We've dropped to 10.8 volts. And the voltage goes up when you turn the voltage down. So about 46, 47 volts, that device is useless. So that's almost an underrating of 50%. You can imagine if that's on the amplifier and it starts to go wrong, what it would do to the drive and preamp circuits. Anything else in between, 36 volts, stable and fine, as you can see. Certainly within 10%, which is what you'd expect really. And at 54 volts, it has shut down completely. The fan stopped and we've actually got less than 1 volt, no current draw. The chip's actually shut down. I'm touching it now to see if it's hot. And it's not over hot. Let's see if it will recover. Yeah, it springs back to life again at about 49 volts. So clearly a long way off our test bench of 60 volts and a million miles away from 80 volts. So it's either a piece of junk or it's a fake, and I suspect the latter. So bearing in mind, I actually bought these for the purpose of getting a fan to operate from an amplifier that has, say, 50 to 60 volts, but it's clearly unfit for purpose. And what's more, it seems to be unfit for the purpose of being used in that amplifier. So whether the genuine ones are any better, I think they must be. I can't believe a genuine manufacturer would say it will handle 80 volts and it cuts out at 50. I mean, that's really bad, isn't it? Unlikely, I think, is the answer. Now, I've actually got another one of these, so I'll check this one as well and see if it's any different. Well, the other module's in circuit now, and this is the original one. I won't bother to show it because it exhibits exactly the same features. So, fake. If you want one that does work, I've shown this again on a previous video. This is brilliant. It's a better spec. It does cost a little bit more money, but this one will run from 16 to 72 volts. And again, I can only test it to 60 and it was fine. And its output is 12 volts fixed up to 1.5 amps. Brilliant. Perfect for using with an amplifier that's got a high voltage where you want to run a fan or some other peripheral stuff. So whether this is the reason those Class Ds blow up, I think you can say it's probably a contributing factor.